Hey guys, it's been a while since I've made a video, but gonna go jump right into chapter 8. But I hope you all did well on your midterm for physics, because I heard that you guys took that about a week ago from the time that I'm making this video. So I hope that went well, and I hope I was of assistance. But we're doing chapter 8 now, which is all about energy. So energy, and if I know that you've all heard the term energy before, and basically energy is everywhere, which is what I think is really cool about this chapter. You can find it in the sun, from the photons that come from the sun. Find it in your car, in your house, in yourself, your body. There's energy in your body in the form of ATP. There's all these different outlets of energy in it, because energy is everywhere, because everything needs energy to function. So that's what I think is really cool about what we're doing in this chapter. So we're gonna dive right into section 8.1, which is about work. And work is basically when you're moving something against gravity. So opposed to gravity, you're doing work. So you've all heard the term like work, like if you have chores or something and you have to say maybe clean up the leaves outside, you're doing work because you're lifting up leaves with a shovel, and the leaves, let's draw the ground here. The leaves, they kind of want to stay on the ground, right? Here's some leaves, and because of gravity, they want to be on the ground. But then you come in with your shovel, right, and you pick them up, and you a force from your arms, you bring them upwards, and you're doing work because you're going against what gravity wants, against gravity. So we do have an equation, because so here you'll notice that this arrow represents a force, right? Force. Then let's say you need to put them in the trash can over here, right? You need to put them in the trash can. Now you lift it like you lift it up with this force, then you move it like 2 meters to put it in the trash can. So that way we have a force and a distance. And all that is encompassed in work. The force and the distance to move the leaves against gravity. So, if you can imagine, the equation for work looks like this. Work is equal to the force exerted, force, times the distance. The distance that the force prolongs for. So let's do a little example problem. Section off a little area for an example problem. Let's clear out this section of Earth. Okay, so let's take a look. Let's say I want to push a car 100 meters, right? Or maybe a wheelbarrow. Let's say a wheelbarrow, just for realistic. Okay, I don't know how to draw a wheelbarrow, but that's my attempt at a wheelbarrow, I guess. And so, say you're gonna push this wheelbarrow 10 meters, okay? So you want it to go all the way over here, which this distance is 10 meters, right? Because that's our SI unit, 10 meters. And to do that, let's say we have to exert a force of 5 newtons, right? So we can actually plug just really easily our work into our work equation, because we want to find out how much work I'm doing. This is for my chores, right? I'm doing this Sunday afternoon. I have to do work for my chores. So I have to push this wheelbarrow this way, okay? I have to move it over to this location, 10 meters away from where I am. How much work am I doing? Because it feels like a lot of work. It's really hard for me. Work equals, well, force. We have the force, newtons. Sorry, I should have done a capital N. That's what newtons is. We have our newtons is our force, and we have our meters, our distance, right? So let's just go ahead and plug it in. 5, I always use parentheses for multiplication, just a little neater, times 10. and we know that that equals 50, right? 50. But 50 what, you're asking? 50 what? It's basically the unit for work is a combination. You'll read right there on the last paragraph of 8.1. The unit of measurement for work combines a unit of force, newtons, with the unit of distance, meters. So we have our newtons, we have our newtons, we have our meters, and we combine them into joules. I'll abbreviate it with J, but it is spelled like this. Joules. Okay? So that is the unit for work. Work is measured in joules. So how much work did we do? With this wheelbarrow problem, we had 50 joules of work, right? Work. Okay? And that's basically work. I mean, we can go ahead and shorten the equation into W equals F times D, capital F, lowercase d, and that is work. Work is equal to force times distance. And you can even, let's say, I'm sure you'll get this type of problem. Let me just do something really quickly. Clear this and then go. All right, let's see. I'm sure you'll get this type of problem. Person X has lifted a brick. This is just off the top of my head, not from your book. A brick, 5 meters, and has done 25 joules of work. How high did they lift the brick? Oops. How much force was exerted, right? I already gave the distance. That was my fault. Right? Okay, so let's go ahead and dissect this equation. 25 joules. What do we know joules are? Joules are a unit for work, and here's our value for work. Let's go ahead and 25, because we're looking at this equation again. Work equals force times distance, right? So we have our W here. We're going to go equals, what's this? 5 meters. What's meter? Unit for distance, right? So we have our distance equals 5. So I'm just going to plug that in there. Yes, it's in the spot of the F, but it doesn't matter. It's multiplication. You can flip it around. And then, well, what do we want to know? How much force? We want to know the F, right? So we don't know the F, so let's just call it F, right? We have we have one variable. We can solve for it easily. So let's just do some algebra. 5 divide 5, and we get force is equal to 5, right? Because 25 divided by 5 is 5, right? But 5 what? Well, let's go back and remember our unit for force, the newton, 5 newtons. If I lifted a brick 5 meters and did 25 joules of work, 5 meters, 25 joules of work, I used a force of 5 newtons with my arms. And that is it for work. The next video we'll be talking about power and mechanical energy. So I'll see you then.